Hello, everyone. The topic for my presentation is going to be sifting through the noise. My name is Sherri, and I work as a data engineer at Alphatex on the Sphere project. Sphere is a threat intelligence system which makes it easier for blue teams to analyze and understand threats as well as mitigate them better. So what does sifting through the noise mean? Well, at least for my purpose, it means understanding and categorizing a very noisy data, specifically when it comes to web service logs. The visual here is not very clear because of the quality. I'm going to try to zoom in. So, for example, like if you've ever checked any web server logs, you would see something like this on the left. And what we want to do is go from that into something that is a bit more structured and makes it easier for people to understand. So a high-level overview about this is all of the steps that we can take into making this possible. The first step, as always, in any data engineering project is data collection. This, for our purpose, is done using sensors to collect and format logs to make it easier for us to parse. The second step is basically storage. Any database will do for this purpose. For example, PostgreSQL, MySQL, or any NoSQL database. That will depend on what kind of queries you want to do and how you want to basically retrieve this data. The third step is data processing. This processing can happen using different methods, which I will go into more detail later on. However, it will also depend on what you are trying to do, depending on your purpose. And the last part is interpretation. For interpretation, we can have a mix of automatic and as well as manual labor kind of interpretations. However, to do this manual interpretation easier for many people, it's essential to have it visualized and visible in a way to make it much easier to understand. So this is how most people think data engineering works. And to an extent, it's true for a lot of people who work for it as well. However, all these methods that are essentially used do have something underneath and are understood by people who have done the harder work for most of us. For our first step, which I mentioned, meaning the collection of the data, we use something called decoys. Now, what are decoys? A decoy is a system or a service that monitors and logs incoming and network traffic. Decoys can be as simple or advanced as you want them to be, but this will always depend on your task and what kind of data you are trying to retrieve, or from what kind of service you are trying to retrieve that data for. My rule of thumb is that, for example, you do not want to make it overcomplicated and waste a lot of time into making something so realistic, because at the end of the day, someone might still figure it out. A good way to make a good decoy is to basically put a login screen on it. For example, a lot of firewalls or VPNs have a login screen, which means that this will in some way entice threat actors into thinking that they are dealing with a legitimate system. Not everyone can fall prey to this, of course. With enough effort, if you, for example, interact with this decoy and try to see the different kinds of requests and responses that you get from it, you can somehow notice that there's some discrepancy from a real system on the decoy. However, there are ways to mitigate that as well, but for most purposes, a login screen is just fine. We can also add some more fun things into it. For example, we can see some specific recent exploit that happened in that system, and we imitate the response that that system would give. So using that, we can make threat actors into thinking that they've actually achieved their exploit, and now they're pinging the beacon to get access, but that will never happen, of course. This is a good way to waste a threat actor's time, as well as collect very good threat data, basically. So, how do we make sense of this noise? Obviously, a lot of this data that we collect from these decoys are very noisy. You can try to understand them manually and go through them, and that's one way to do it, but that is a task which is very hard and takes a lot of time and effort, which means we have to look into more automatic ways to do this. One of the ways that I've seen is anomaly detection, and I try to understand how anomaly detection could work in this case. However, that doesn't really work in our purpose, because a lot of this data is not for a real system, and a lot of the responses we give are not the real one. So we cannot know a good way to understand what is, for example, an anomaly or not. For this specific use case, for the logs themselves, we need to understand semantic context, which means it's very hard to explain, but basically semantic context just means what we understand as humans relating to the words, and in that way, even the logs themselves, when they are written to be human readable, but they are, in most of the cases, it's very hard to read them as a person. And to make the semantic context understanding at least somewhat automatic, we can use a lot of different other methods, which I'll get into right now. So first of all, we need to get into a bit of the specifics of what makes an exploit. And that works through identifying where the exploit can be contained in this log data. Usually when we look at web server logs, for example, PHP or Nginx, whatever web service that you want to look at, they do not actually register or log everything that's part of every request. Because, to be fair, it's a lot of data that can go through. This means that you have to go a bit deeper and make sure that you have captured everything from this request that you got into your decoy. And usually the highlighted points that I have mentioned here usually might contain some kind of exploit, but that's not always necessary. If we look at one specific case, which is a very recent exploit, it's this CVE 2024-4577, which is an exploit that happens on the PHP CGI, and it's an argument injection. What we can infer from this log that we have collected here, I know it's not very visible, but let me zoom in. Okay. So what we can infer from this, we can see that the request query string itself is the actual exploit, which is doing the malicious thing, and in the form data we have it's where the shell is being contained. Okay, so knowing this context, that each one of the different parts can have the exploit or contain it, I went into researching into many different articles and different research papers that I managed to find. And one of them is actually linked here. So if anyone wants to take a look at this article, If you get the slides later, you can check it out, because a lot of these things are very extensive and would be very hard to explain in 30 minutes. But essentially, this is a high-level overview of what kind of different ways that we can use to do some sort of automatic analysis for this data. What I actually went with was specifically clustering. And after considering many different methods, I realized that specifically clustering is very important, because all of this data can be very noisy, and it can have a lot of things, which means that we need to have some way to categorize them and find which kind of log can be similar to the others. That is what essentially clustering does. It clusters logs that are very similar to each other and adds them to a group. And this means that it can reduce the amount of automatic or manual labor from, I don't know, thousands into maybe tens of manual checks or automatic ones. So here's where I've actually want to show something that I've built for this specific presentation, at least. I needed to find some way to try all the different methods that I mentioned, and like actually adding them to the database and querying it back to see if the clustering worked was very tedious. So I decided to put it all into this fancy GUI using PyQt and PyOpenGL. I also really wanted to make it easier for me to somehow tweak the values and see how that reacts with the data itself. And right now I'm going to show you the specific GUI. So because I couldn't really demonstrate this live, although that was my preference, I recorded this video of specifically one of the feature extractions. And the visualization itself is happening here in the 3D space. So what essentially this part, what essentially clustering does is split it into many different clusters. This is done through, first of all, extracting the semantic context from it, which is, it can be used with many different methods. So you have to do feature extraction. You can use TF-IDF, which is used in many search engines. Or what is the new thing, and even large language models use it, is embeddings. And embedding seems to be the answer, at least for this case, even though TF-IDF had some achievement to it, but it still wasn't enough to actually split everything as tidy, let's say. After you've embedded it, after you've embedded a log, which is essentially just a sentence, which tells you a bunch of information. After you've embedded it, it splits itself into, not split, but it projects itself in a higher dimension, and using that, we can use dbscan, which is the clustering method itself. And dbscan makes the clustering. However, through the embeddings, we can reproject the higher dimensional points, which can go, depending on what kind of model you're using, it can go from 512, 1024. And in this case, I actually use the 512 model. However, I would have to basically remove parts of the request itself to make it actually do the embedding, because some of the requests went on too long, and there was like a lot of parts in that request itself. So here's just some examples. As you can see, the requests themselves have a lot to it in parts. However, we can see that, for example, this one has been split into this specific endpoint. And it's not only endpoint specific, it actually takes the whole log and sees the similarity between each different logs and adds them to the cluster. So this was the first version of this visualizer. I've actually have worked very recently hard to try to make it ready for today and to have it open source for everyone to check out. But that wasn't the case, and the code really needs some reworking. So hopefully in the next few weeks, I will have it ready, and maybe you can ask me for the GitHub, and I'll be happy to share it. So, as I showed before, trying all the methods is very important, especially because a lot of people have worked on these problems before, and that means that there are solutions to our problems before we even thought what the problem was. A lot of people have done a lot of work for this kind of thing. Some promising concepts that to look into, which I found interesting, was, for example, fine-tuning of base embeddings model. So you take the log data that you want to do specifically and use that to fine-tune your model to make it more efficient to do the specific embedding for that kind of data. We can use, after we've clustered all this data, we can use some sort of regex to see exploits, to extract some specific kinds of exploits. For example, path traversal, you can easily see it because of the dots and slashes. And automatic tagging through language models. This is something which I've experimented with. Still needs work, I think. And if you're interested, I think it's something that it's good to look into. So this was a very short and very fast-paced overview of how this could work. Clearly, there's a lot of research that has gone into the people that have, first of all, made all of these models. For example, in the previous one, I had all MPNet base v2. This is the research paper that actually saved my project because it explained things in a way which it was very easy to understand. There's also a link to this paper. And at some point I was really stuck because none of the methods when I was doing the tweaking manually were working, and not to the extent that I really wanted. And this paper had some way of actually using other models which were machine learning models to sort of optimize the epsilon value, which is a value that is essential when you're using the clustering algorithms, and basically decides how the clustering will be done. It's a simple value of from 0 to 1, for example. So that was my talk. Thank you everyone for attending.